Hi, welcome to Mrs. Thompson's classroom. Today we're going to be continuing with our unit in trigonometry, and we're going to be talking specifically about the law of sines. And the law of sines allows us to solve triangles, in other words, find all the angles and the sides, even when it's not a right triangle. So let's take a look at this picture. We can see that if I drop an altitude from C down to AB, I can relate angle A and angle B both to H, because the sine of A would equal H over B, because H would be the opposite side. But I also can relate the sine of B as H over A, because H is the opposite side and A would be its hypotenuse. Now both of these equations can be solved for H. Okay, now these H's are the same. They are the same distance, the same height, the same altitude of the triangle. That means these two things are equal to each other. Now, if I divide the sines both to the other side, what I end up with is B over sine of B equals A over sine of A. And this right here is our law of sines. Inside any triangle, this is going to be true. Now, the reality of it is, if I turned the triangle and I dropped an altitude from A down to its opposite side, and I used that height, I would also find that C over the sine of C is the same as well. So regardless of which angle and which side, we can always write these ratios. So that's going to allow us to solve some triangles. So in this first triangle, let's just set up the ratio. So the first thing I notice is that this 100-degree angle relates to the 14 side. So I can put 14 over the sine of 100 degrees. Okay? Then if I take angle Y, it would relate to the 10. So I can have 10 over the sine of Y. Now this sets up a proportion with only one unknown, so I could definitely find Y. And if I know the 100-degree angle and I know Y, I could find X, because all triangles add up to 180 degrees. So my last ratio then would find side X over the sine of X. And since I just found angle X, I now would only have one unknown of side X, and so we could solve the triangle. So let's do that process with this one. So this 40-degree angle would relate to the 12. So I'll have 12 over the sine of 40. Okay? The 8 is going to relate to angle D. So I'll set this equal to 8 over the sine of D. Now if I cross multiply, I get 8 equals 12 sine of D over sine of 40. And so if I what I can do now is multiply the sine of 40 to the other side and divide the 12. And what that leaves me with is the sine of D equals 8 times the sine of 40 divided by 12. Now I need to figure out angle D. So how we do that is we do the inverse of the sine function. So angle D is going to equal the inverse sine of 8 sine of 40 divided by 12. Okay, and then we can go to our calculator. Now that is in 40 degrees, so we want to make sure first of all that your calculator is in degrees. And then you should find that above the sign button there is an inverse sign. So we'll use that. 8 times the sine of 40 divided by 12. And we get that this angle is 25.37 degrees. Okay, now once I know angle D, then that is going to allow me to find angle B. So angle B is going to equal 180 minus 40 minus the 25.37. And so we get 114.63 degrees. So now I know all three angles. And all I am left to find is side B. So I'm going to set up my other ratio. Now that I know angle B, and this one will cross multiply and get me 12 times the sine of 114.63 divided by the sine of 40 equals B by taking this proportion here. So now we can go to the calculator for that. And what I end up with is that side B is 16.97. So we have found all three sides. Okay? So hopefully that is going to help you just see how the law of sines work. Next time we'll do a variety of examples in different types of triangles and figure out when can we use law of sines and when can we not. Okay, so I will see you then.